In this lesson, we're going to review problems involved in graphing and writing equations of ellipses. So the first problem is from number 5, chapter 9.4, and it asks to graph the equation identified below, 49x squared plus y squared is equal to 49. Then identify the vertices, co-vertices, and foci of the ellipse. Well, we recall that one of the formulas or the equations for the ellipse is going to be x squared over a squared plus y squared over b squared. Now it could also be x squared over b squared plus y squared over a squared, depending on the orientation of the ellipse. So if the ellipse has a major axis, the axis running through the longer portion of the ellipse in this direction, then the a squared value will go under the y squared. And if the major axis is a horizontal major axis, then the a squared value goes under the x squared. So the first thing we want to do is we want to rewrite this equation here to make it look like this formula to the right. So what I'm going to do is I'm going to divide every value here. What I want is a 1 on the right-hand side of the equation. I'm going to divide every value, every term in this equation by 49. So I end up with x squared over 1 plus y squared over 49 is equal to 1. And I can rewrite that as x squared over 1 squared plus y squared over 7 squared is equal to 1. Now the way that you identify which value is the a value and which value is the b value is to take a look at the denominators. The a value is going to be greater than the b value for an ellipse. So we know that the a value is underneath the y squared term or value, and that therefore the major axis is going to run vertically through the ellipse. So the orientation of this particular ellipse that we have is correct. However, if the a squared value were larger underneath the x squared value, then the ellipse would be oriented something like this. So the major axis running horizontally through the elongated portion of the ellipse. But in this case we have it correct. We'll leave the ellipse situated here. We know that the, in this case, we know that the origin is going to be the center of the ellipse. So let's rewrite the problem in terms of the way that we've learned the equation, so that the x squared value is second in this case because it has the b squared value. So y squared over 7 squared is equal to, plus x squared over 1 squared is equal to 1. So I know my a value now is 7 and my b value is going to be 1. And all the a and b values tell you is the distance from the center to the vertex or the co-vertex along either the major axis in the case of the a value or the minor axis in the case of the b value. So we know that the a value is 7 units along the major axis. We know the major axis runs through the length of the longer portion of the ellipse. So I can identify this point here as 0, 7, and this point here as 0, negative 7. And these are our 2 points for the vertices. Now the b value represents the distance from the center, again, along the minor axis to the co-vertices. And here I'm going to move 1 unit to the left and 1 unit to the right. So I have a negative 1, 0 as the location of my co-vertices. So these are the this is a vertex, and this is the co-vertex. And so this point here will just be 1 unit to the right from the origin at 0, 0. Now the last thing I need to do is I need to find my foci. And I know that the equation for c, which is, again, the distance from the origin to the foci, is c squared is equal to a squared minus b squared. And I see that c squared in this case would be 7 squared or 49 minus 1 squared, which is 1, or c squared is equal to 48, or c is equal to plus or minus 4 root 3. So now all I have to do is count along the major axis because the foci is on the major axis. 4 root 3 units up and 4 root 3 units down. So I have 0, 4 root 3 as one of the foci, and the other is going to be at 0, negative 4 root 3. So now I've properly identified the vertices, co-vertices, and foci of the ellipse, and I can now move on to my next problem. In number 15, I'm asked to graph the equation and identify if it is a parabola, circle, or an ellipse. Okay, so we recall that one of the things that we want to do is we want to make sure that in the case of the ellipse, that we have a value that's a 1 on this side. And we know that in the case of a circle, that the coefficient in front of the x and the y's are going to be the same. So we're going to rule out that this is a circle because the coefficient is 4 for this equation for x squared, and the coefficient is 16 for this equation, so we know it's not a circle. We also know it's not a parabola because the parabola, remember, has one variable that doesn't have a squared unit and the other value that does. So in this case we have both variables that are squared, so it cannot be a parabola. So it must be an ellipse. So what we want to do is we want to graph this equation now that we've identified it as an ellipse, and we want to first rewrite it in a form which represents an ellipse, having the 1 on the right hand side. So the way that we do that is we divide every term by 64 to make this equal to 1, and I get x squared over 16 plus y squared over 4 is equal to 1. Okay, so what are my a and b values? Well, I know my denominator underneath the x squared is going to be larger, so my a value corresponds to 16. And I know that 16 is a squared, so my a value is going to be 4. I know my b value, b squared is equal to 4. My b value is underneath the y squared variable, so b is going to be equal to 2. So now I can graph this particular ellipse. I know that because the b value is underneath the x squared variable, that the major axis is going to be a horizontal axis. So I draw my ellipse that way, move it over the origin here. So I know it's not translated, at least in this section. I can identify my co-vertices as 0, 2, and also at 0, negative 2, and my vertices, because they correspond to the b value, and my vertices at negative 4, 0, and 4, 0. So now I've properly identified this as an ellipse. I've identified the vertices and co-vertices, and I've graphed the ellipse. Okay, in the last problem, the book is going to ask us, or the book is asking us to write an equation of an ellipse with a vertex. This is number 9. So we jumped ahead and now we're coming back. Write an equation of an ellipse with a vertex at negative 7, 0, and co-vertex at 0, negative 1. So let's identify our vertices. We know, again, the center is at 0, 0. So we're going to mark our vertices, 1, 2, 3, 4, 5, 6, 7. And here is one vertex. And I know the center is at the origin, so my other vertex is 7 units in the opposite direction, somewhere about here. And then I graph one of the co-vertices at 0, negative 1, and my other co-vertex is going to be at 0, positive 1. Okay, so I know my b value is just going to be the difference between the origin 0 along the minor axis to this point, which is going to be 0, 1. So I have 1 unit, and my b value is equal to 1. I know that my a value is going to be a certain distance along the major axis, 1, 2, 3, 4, 5, 6, 7, from the center, which happens to be the origin. So I know my a value is going to be 7. So now I can graph this particular ellipse. Since the ellipse is oriented such that the major axis runs through or is horizontal, I know that the a value will go under the x squared value for the ellipse. So I write the equation is x squared over a squared plus y squared over b squared is equal to 1. So all I have to do now is fill in the values. X squared over 49 plus y squared over 1 is equal to 1.